In this video, we are going to learn how to describe functions mathematically that are not necessarily linear, that might have a bunch of different things going on. So we're going to title this Describing Functions. Don't forget to put today's date in the corner. All right, so let's go ahead and write down some of the key vocabulary. Some of this is new, some of this is old. So we have intercepts. We've talked about that a lot this year. This is an important one. They could be either X or Y. And remember that what that means is that is where our relationship, it could be a line, it could be something else, crosses an axis. So this is cross or even touch. It doesn't have to actually cross, it can just touch. We also have maximum and minimum points. This is a new term, but it means kind of what you might expect it to. So the maximum or minimum, that's going to be the highest or lowest point on a graph. Okay, we can describe sections of a graph as being increasing, decreasing, or constant. This is new. That refers to, we've talked about this before, but we're formalizing that language. And this is always referring to slope. So increasing interval, increasing, decreasing, or constant are the three options. And that always refers to slope. Slope going up, slope going down, slope staying flat. And then one of the newest parts we're going to be talking about is intervals. So that's just a way to describe, to kind of like chunk up a graph into vertical chunks to describe what might be happening in the different chunks separately. So we can call that specific parts of a graph. Vertical chunks of a graph. And we use intervals to describe increasing or decreasing or constant. Or we could also describe it as being like a linear interval versus a non-linear interval. Like that's like something we use in combination with the other things. Okay, let's draw an example of the type of graph that I'm talking about. It should be roughly -7 to 7 in both the X and the Y direction. Or sorry, I guess we're scaling it by ones and I'm labeling the 5 mark. Okay, and then let's graph this together. So we're going to start at -7, -4. Right down there, -7, -4. And then let's put another point at -4, 1. And then we're going to connect those with a curved line like that. So that would be a nonlinear interval or a nonlinear segment. Then we're going to go flat. So we're going to do a constant interval until we hit 0, until we hit the axis. Then we're going to show that we don't always have to be perfectly lined up. So let's go to 2.5, 5.5 up here. And we're going to do a linear increasing interval up to there. And then let's go to 4, -2. Let's do a very steep decreasing interval to get down there. And then finally, let's go to 7, 2. And let's do a curved interval up to there. Okay, so this is all one graph. Is this graph a function? Yeah, right? There doesn't ever overlap on itself. There's no two y values for the same x value. Is it linear? No. There's linear sections of it, but the whole thing is not linear. Okay, so let's say what we can say based on our vocabulary that we wrote down. Let's start with the intercepts. So we have x-intercepts. And in this situation, we have 3 of them. So let's write down all 3 x-intercepts. We have one over here at negative 5.5. So negative 5.50. We have another one over here at 3. It's not quite 3.5, but let's pretend it's 3.5. 3.5-ish. 0. And then we have one last one at 6.5, maybe. Once again, sort of. 6.50. So there are 3 x-intercepts. 1, 2, and 3. And then let's see how many y-intercepts we have. So there's one y-intercept right there. Nowhere else on the y-axis does it cross, which makes sense because it's a function. If it were to cross the y-axis more than once, that would mean that it wouldn't pass the vertical line test, right? Okay, so there's one y-intercept at x is 0, y is 1. One y-intercept. Okay, let's see what else we've got. So we have a maximum and a minimum. So the maximum, since that refers to the highest point, we report the y value for that, right? So we go to that highest point right there, and we look over at the y-axis, and we see that's at like 5.5. So the maximum at 5.5, and the minimum, oh, that's not the minimum. This point is lower because we're literally talking about low on the y-axis, and this point is at negative 4. So minimum at negative 4. And we don't report the full coordinate for that. We just say the y coordinate for those. Okay. Next, we have increasing, decreasing, and constant. So obviously, this graph does all 3 of those things. So we can't just say the graph is increasing because it does a bunch of different things. This is where the intervals come in. So we're going to report for each section what it's doing. So we can say it is increasing from, and then there's a bunch of different parts. So it's increasing from when x is negative 7 to negative 4. These are all x values. It's increasing from 0 when x is 0 to 2.5. And it's increasing from negative 4 to 7. So there's 3 different intervals in which it's increasing. You're sometimes going to see these written using inequality notation. So from negative 7 to 4, we could write that as when the x values are bigger than negative 7, but less than negative 4, right? That's like an alternative way to write that. We could say that the x values are bigger than 0 and less than 2.5. We could say it's when the x values are big. Oops, sorry, that one shouldn't have been a negative. That's a positive. The x values are between 4 and 7. So you're going to see it written both ways. I'm okay if you write it out for me in words, but you'll need to be able to like read it using that inequality notation as well. Okay. And then we also have a decreasing interval. So it's decreasing from 2.5 to 4. So that would be when x is greater than 2.5, but less than 4 would be the other way to say that. And then constant. A constant interval is from -4 to 0. -4 to 0, or when x is greater than -4 and less than 0. So for your practice problem, you're going to sketch a graph that has two x-intercepts. You can decide where the x-intercepts are, but it has to have two of them. It's going to have one y-intercept and only one. It's going to increase below 2. So when the x values are less than 2, it should be going up. And it's going to decrease above 2. So once it hits 2, it needs to start going back down again. Sketch a little graph of this and check it. Good luck.